Good day everyone. Today we're going to talk about the moment of area method, and we are also going to solve the problem assigned to me, which is a problem 9.97. So let's have a quick review of moment area method. Moment area method is used to determine the slope and deflections in beams. Area of bending moment diagrams is utilized for computing the slope and or deflections at particular points along the axis of the beam or frame. In Theorem 1, the change in the slope of a beam between 2 points is equal to the area under the curvature diagram between those 2 points. Theorem 2 states that the vertical distance of point B on an elastic curve from the tangent to the curve at point A is equal to the moment with respect to the vertical through B of the area of the bending moment diagram between A and B, divided by the flexural rigidity, EI. So, let's proceed to the problem, which is the problem 9.97. For the uniform cantilever beam and loading shown, determine first the slope at the free end and the deflection at the free end. So as you can see, we have two forces applied on the beam, which is going downward. And first, we have to place a reference tangent at A. And note that slope A is equals to 0. So A, the slope of the free end. So draw the diagram we have to draw the diagram by parts. And as you can notice here, it is a negative sign since the force is going downward, and therefore the moment is a negative sign. And by the first moment area theorem, we have here A1 is equals to 1/2 quantity of negative 2PL, which is the length of the beam, over EI, quantity of 2L is equals to negative 2PL squared over EI. Our X bar is equals to 2 over 3, quantity of 2L is equals to 4 over 3L. Next, the second area, area 2 is equals to 1/2 quantity of negative PL EI times L is equals to negative 1 PL squared over 2 EI. X bar, our X bar 2 is equals to L plus 2/3 L is equals to 5 over 3L. So our slope, the slope is the summation of the area. So our slope B over A is equals to A1 plus A2 is equals to negative 2PL squared over EI minus 1PL squared over EI, which is equals to negative 5PL squared over 2EI. And our slope B is equals to slope A, which is 0, plus slope of B over A, which is equals to negative 5PL squared over 2EI. So our slope is equals to 5PL squared over 2EI. Next, the deflection at the free end. So the deflection BO, so by second moment area theorem, we have here the deflection B over A is equals to A1 X bar 1 plus A2 X bar 2, which is equals to negative 2PL squared over EI, quantity of 4 over 3L, plus negative 1PL squared over 2EI, quantity of 5 over 3L, equals to negative 7PL cubed over 2EI. And our deflection B is equals to deflection B over A is equals to negative 7PL cubed over 2EI, which is going downward. So that's the end of the solution, and I hope you've learned something from our